Hey everybody, welcome back to Tech Talks with Coding Nomads. My name is Ryan Desmond. I'm a co-founder of Coding Nomads, and I'm here today with Nick Rose. Nick is a senior solutions architect at Google with the Global Partner Engineering team. Thank you, Nick, for being here with us today.
Totally. Thanks for having me. Super excited.
Nice. Likewise. It's a pleasure to have you here. Nick and I have been chatting for some time about doing this talk. We actually grew up together many years ago in Truckee, and I've been watching him soar through his tech career for many years at SAP and now Google. And I've been hounding him down to hop on one of these tech talks. So I'm glad we're here. Thank you.
Definitely.
So my first question for you, Nick, is what does it mean to be a solutions architect on the global partner engineering team at Google? What does that mean? What do you do?
Yeah, no, fantastic question. If you do find out what that is, let me know. Because half the time I'm not even sure.
Right.
No. So for me and my team, our focus is on building joint offerings with our GSIs, global systems integrators. So I work with companies like Deloitte and Accenture, Atos, Wipro, and basically I help them in consuming Google Cloud technology to help solve some type of business problem, typically in a type of industry, sometimes more horizontally like security or high performance computing. So I basically spend a lot of time talking with these large companies and with our product teams and kind of helping marry the best of Google Cloud technology with the industry expertise of all these GSIs in building, biomedical research platforms, insurance underwriting platforms, anything to help solve big problems that they're seeing with their customers.
Nice. Sounds interesting.
Yeah, no, it's been I've been here a little over 2 years and I've loved it. It's been fantastic so far.
Very cool. Very cool. So, as I mentioned offline, in my professional career, I've been mostly on Amazon, and mainly because that's where the company that I was working with, that's what they used, right? So most of my professional experience in working with large cloud technologies has been on AWS, but I've always been aware of Google Cloud, and I've kind of poked around in there a few times. But I'm very, very interested and curious to learn, especially from you, about Google Cloud. Do you call it the Google Cloud Platform, or is it just Google Cloud?
Yeah. Google Cloud is the company, and the product itself, the platform is Google Cloud Platform, GCP.
GCP. Okay, great. So on that note, what are we going to learn today? What are you going to tell us about?
Yeah, totally. So I thought I'd just give you a little bit of background on it, talk about some of the things that kind of help differentiate GCP compared to Azure or AWS. Both great cloud providers. I've used AWS in the past myself, so I'm just as guilty as others. But a few things that are more unique to Google Cloud, and I really wanted to end focusing on ML, which is a big area for Google, and talk about some of the out-of-the-box ML capabilities we have. Machine learning is a huge topic in today's world, and not everybody's a data scientist, myself included. I'm lucky I can spell ML. So I wanted to show you some of the cool things on our platform that we have to help address developers' needs when they're looking to incorporate AI and ML into their products.
Very cool. Well, I'm super interested. How about we go ahead and jump in? You want to start sharing your screen?
Sure. Sounds great.
Oh, look what we got here. Is that the list of the best coding boot camps in the world for 2021?
I think so.
I like your tabs. I like your tabs up there too. Are those all tabs up top?
I think I'm sharing the wrong window. That's probably why. I was just sitting there saying, I'm like, oh, I thought it was my deck. Yeah, my tabs are like highly excessive. I've got way too many tabs. Although thanks to Chrome, I can group my tabs and collapse them as needed. So I'm getting better at doing that. Oh, and I stopped sharing again.
Yeah, I've actually just discovered profiles, browser profiles, which are really great because I'm doing lots of video recording and stuff like that, so I can switch back and forth from I've got my entertainment profile, I've got my work profile, and then I've got my general profile.
Nice. Yeah, it's super helpful.
Cool.
Okay, can you see my deck now?
Yep, deck looks good. Why Google Cloud?
Yeah, I use technology so much I can't even share a screen. So cool, man. So let's get into it. Why Google Cloud? Obviously, whenever I'm speaking, I'm always speaking on behalf of Google, but really this is just my personal view of what I think makes Google Cloud really cool. And so, one of the things I love about Google is been around forever. It's, when you plug in your internet and you're testing your connection on your laptop, what's the one thing like most people do? They go to Google and they Google something, right? Can I even Google something? Cool. And so Google has truly been around for a long time. They've created so many great products. And as it went on, they started to say, hey, we got all this cool technology. How can we help bring this out into the world and share some of the awesome things that we have? And so that's where Google Cloud started. There's a longer back history behind that I won't get into here. It's not as interesting, but it's a big company. We have tons and tons of regions out there, and we're continuing to invest in our network. It's an incredibly large network. We highly invest in laying a lot of subsea cables because we really want to have control around the traffic of people on our platform. And even, to normal users in Google itself, if you're using search or Gmail or YouTube or anything else, because a big thing for us is making sure we have control over where those packets and requests are going, as far as speed and security and things like that. So a very solid network. In fact, most cloud providers. Oh yeah.
Can I ask one question on that previous slide? So are the blue circles, are these data centers, or what? When I see current region with 3 zones, what does that mean?
Great question. I totally glazed over that. Yeah, so these are like data centers that are out there, right? So these are places where Google is actually built a data center to help host and move traffic. In fact, there's a really cool video on like an intro to data centers that Google has on YouTube. I suggest that you go look at it. It's a really interesting video just to see all the different layers of security they have and how they actually handle this. And Google actually very heavily invests in building the hardware for these data centers. So we actually are one of the largest like hardware, manufacturers, so to speak. I don't want to speak out of term on what the actual fact is, but like we build almost everything from the ground up when it comes to our data centers because we want that kind of control when it comes to each of these different places. And you can see there's points all over the world because we know that everyone should have some type of access to the internet, and we want to be able to give that access as best we can and really provide the best service to all of our users and customers.
Nice, cool.
This is just a small fact. So like most cloud providers, they have a hot potato way of handling traffic. So as soon as you make a request, they will just throw it out into the public network as fast as they can and let it go. And then it gets to them. They take some kind of, they do whatever they need to and they send it back to you. Very uncontrolled kind of matter. We take a cold potato approach where we actually want your request to get onto one of our points of presence, which in that map, that it could be one of the data centers or one of the edge points, as soon as we could, because then we know that it's on our network and we have complete control over that. And so that gives us a lot of that control and security that we look for in our requests. So like the network alone, I think is a huge advantage for Google Cloud. It's something that's been building up over a long time. And the fact that Google Cloud can now grow and develop on this amazing network that Google has built, I think is a positive thing for Google Cloud users themselves.
Nice. Yeah, makes sense.
Security, I mentioned. I think security is incredibly ever growing a need and concern for most people. And Google is they're completely familiar with that. They're no stranger to it. This is a really cool example that I love talking about. So if you're familiar with the Spectre and Meltdown issues that happened, this was some number of years ago. I can't remember the exact year. But there were problems with chips, like vulnerabilities that were out there within these CPUs. They were discovered by Project Zero, a team at Google, that all they do is they go and do this type of research. And so they actually found these. They were able to work directly with those manufacturing companies, as well as modify all of the code before it was even announced out to the public. So they made changes to make sure Google's network was safe. And then they were able to deploy those changes with zero downtime to any of the servers that were there. So the Google Cloud Platform has a lot of capability built in to be able to roll out changes and make sure that you're not having to shut down systems to make those changes and spin it back up. So your uptime is dramatically higher, and there's a lot less risk when you actually do need to improve the network and roll out changes to hardware and software. But security is something that we continue to invest in heavily, heavily, heavily. And this is just kind of one fun example of that.
I know that, we've and I'll try not to bring up AWS too many times, but I know that there's been several outages, like AWS outages, like where S3 went down in the in the US East region, you know, and it brought down like a third of the internet. Um, has Google Cloud basically has Google Cloud had any similar major, because you basically said zero downtime, which I think is fascinating. Even keeping a simple website up with zero downtime is a tricky task. Keeping an entire cloud platform up with zero downtime is, you know, basically miraculous. But you know, but has Google had you know, has it had the same kind of issues that I've seen, for instance, with AWS, and kind of like, you know, whole regions going offline for an hour or two and bringing down part of the internet with it?
Yeah, so that's a good question. That's a great question. I wouldn't say we have zero. We definitely don't have zero downtime as a whole.
Mm-hmm.
We do have outages in some capacity. I don't know them off the top of my head, although I'm sure there's places you can easily look and see them. Some of those have been more severe. This is actually a good example of one of those where you know there is potential for it. There have been other security issues that have gone in and brought you know, larger areas down, which has led to other growing learning things for us to build on. So it definitely happens for us. I don't know off right now what our, you know, our downtime is or for the past year, so to speak, but it is
Right.
quite small.
Right.
So yeah, I won't say that we're zero downtime all the time, but in general we do pretty well in comparison. Cool. So Google Cloud itself, there's a lot of different things that play into Google Cloud. Google Cloud has a lot of products within it. So obviously I'm focused very intentionally on Google Cloud Platform. There are other services like Apache and Orbitera, which are products that, you know, we've acquired over time and have been brought into the Google Cloud family. Plus Google Cloud touches and supports a lot of other, you know, areas within Google, whether it's Chrome or Maps or Android. G Suite actually is within Google Cloud. And so there's a lot of things when you talk about Google Cloud itself. I'm really kind of focusing on Google Cloud Platform, since that's kind of the base of it, and really where all the building blocks and solutions eventually start to evolve from. So just kind of a preface to that. And this is an eyesore. I don't intend to walk through all of this, but I wanted to bring it up because it just shows all the different capabilities within Google Cloud. And you know, AWS and Azure, they have plenty of services as well. AWS has been around for a long time, so they're even steps ahead. You know, we're playing catch up in some areas with them, just because they have that lead time on top of Google Cloud. But we have tons of different services to support a number of different use cases that anybody might need, whether it's from storage, big data, developer tools is growing a ton for us. Security is an area actually where I'm spending more and more of my time, especially when you look at some of our security products like Chronicle for SIM support and BeyondCorp for like zero trust. How do I not have to have firewalls and things like that within my network? How do I actually provide a true zero trust approach to any kind of access of applications? So there's tons and tons of blue hexagons, and there's actually a slide at the bottom where I give kind of a quick snippet on how to see all those, but I'm not going to touch on all these. I'm only going to touch on some, but just to point out the fact that there is a lot of capability within Google Cloud to support many, many different use cases.
Nice. And I was kind of realizing as you're mentioning this that for, you know, some people watching, kind of understanding what Google Cloud is used for, or any of these cloud platforms are used for, might be a little bit confusing. And basically, if I'm going to try to explain it in layman's terms, is that Google over, you know, decades has been building all these data centers and all this incredible software to run their internal services like Gmail and YouTube and, you know, Google search and all the other things. And at some point, you know, a while ago, these large companies kind of realized that they had so much capacity and these data centers and stuff that they could basically open up some of these services so that other companies could basically run their companies on, for instance, Google's infrastructure, right? Like they can use Google storage, they can use Google's compute engines, they can use databases hosted in the Google Cloud. They can, you know, as we're going to learn with you, you can use Google's ML tools to run machine learning models. And rather than having to build all this stuff up from scratch or have a server, you know, in your office where you're hosting all of your stuff, basically now we can, it's offloaded right from the server in the closet to being where we all just use, where most of us use these cloud platforms to run our entire businesses. Is that, would you say that's a general?
Dude, you are spot on. Actually, that's a really good call out. And that's so true. That's exactly what it is. I mean, why should I spend a ton of time and money thinking about, okay, how much hardware am I going to need in the coming year or 3 years or 5 years? And gosh, that's really expensive. And then I got to pay for like a place to put it and the electricity and people to run it and maintain it. Now I got to upgrade all these libraries. Like that is exactly what cloud is solving for, is taking all that away so you can truly focus on what you're trying to build and like running your business and how you can continue to improve that.
Right.
And the scalability of it, right? If I'm buying my own hardware, I'm limited to that hardware, and especially today, there's a university, a researching university that does light sheet microscopy. I'm probably screwing up that term, but where they take images of one cell of a brain of a seahorse, so to speak, and those images are 5 petabytes each to be able to get down to that. So they actually have a problem where they're storing, all these petabytes of data, but they only have so much hardware. So they're actually deleting old images to be able to make room for new images. And so they're losing data and not being able to perform even more research further, moving past what they have today. And it's a fun story and a good example of what cloud can actually do for you.
And then you hop on the phone with them and you're like, do I have a solution for you?
Yeah, let's do this.
Yeah, very cool. And then another term for that, just to tie that off, is and correct me if I'm mistaken, but it would be commodity hardware, right? Is that
yeah?
So basically, instead of and for you'll hear this term thrown around like commodity hardware or commodity infrastructure, where instead of basically you buying and hosting and maintaining your own servers, we're basically renting space on commodity hardware or basically on Google's data centers.
Yeah, totally. And that's great. And that's so true. Yeah, it's, I'm renting space and now I have room to do this. And then you start getting into the place of, well, I might need more space. So how do I then reserve a little bit of extra for just this one thing? And then dial it back down. And I'm gonna start going into a rabbit hole here. I need to not do that. Well, but it comes into so many different use cases there too. Right. So you're spot on. It's a great thing to point out and make people aware of, because I don't think people always realize that or think of it in terms of the capabilities that cloud can provide you.
And one example that I use all the time, I think, for understanding the scaling problem is, imagine that you run a website, the world's foremost website on Halloween costumes, right?
Nice.
For 11 months a year, you get like 7 visitors a month. And then for 1 month of the year, you get like 70,000 a day, right? And
completely.
So how do you deal with that, especially if you're running your own, like, worst case scenario, you have your own server in the, in the back of the office. How do you go from, managing 7 users for 11 months, which would be very, very cheap, right? You don't need 70 servers to manage that. You need one very small server. You could host that off your laptop, right? But then how do you seamlessly go to 70,000 users a day? And when we're talking about scalability, that's what we're talking about. How can we scale both up and down based on load and demand?
Dude, perfect example. I love that. Nice. That is spot on.
All right, I'll quit interrupting you.
No, this is great. That's actually a really good call out, is, not everybody's aware of what cloud is and what it can do. And especially when you look at all these different things, like what does it mean? And I'll say that there's also cloud.google.com/solutions is another good link. It's not on here, but that starts to talk about how do you actually take some of these, blue hexagons, so to speak, and put them in together in a meaningful way, which is what, people like me and my team do.
Cool. Nice.
A couple other kind of cool things to point out before we get into some of the ML stuff. One big advantage for us is flexibility within VMs. So as you're actually, putting together, you're setting up virtual machines in Google Cloud for your use. We have a ton of flexibility in how you can do that, which is a big advantage for us. Other cloud providers don't have the full kind of flexibility we do. And that's important because, you can release a certain set of machines that, machine types, meaning like how much CPU do I have, how much RAM, all the different things that go along with it, storage potential capabilities, what type of CPUs, like do I have a CPU or a GPU or even I'll talk about TPUs in a second, but like the power of those processing units. Google Cloud, a big thing for us is the flexibility in that. So people can really customize the workloads they're building on Google Cloud. And you're not necessarily paying for something that's more than you actually need, or struggling with something that's less because you can't you might fit in between somewhere. You might be using you might be using one machine for very simple, basic applications, and you might need another VM for a lot of like machine learning intensive stuff because you're doing your own TensorFlow. Those are two very different use cases in how you set up a VM. So there's a lot of capability you have within Google Cloud on the flexibility of that, as well as how do you tie persistent disks to those, and really customize for your own environment. So that's one big advantage within Google Cloud, I think, that not everybody is always aware of or realizes.
And in what we're looking at here on the slide, is this actually like the Google Cloud CLI? Like, is this the actual commands you would run?
Totally. You're spot on.
If I want to resize my existing disk to 20 terabytes, I just can run this one simple command and it'll just do it. And
then it's handled for you.
Yeah, that's pretty amazing. That really is. I've hassled with that kind of stuff many times. So this looks quite nice.
Yeah, and there's a UI for a lot of this stuff, but the CLI is great. Our CLI tools with the G-Cloud library are awesome. Yeah, so it's really cool. Just like with one simple command, it's taking care of all of that for you, and that's it. That's all you got to do. Nice. And you now have continued to grow, it goes back to that story of I'm changing my business for a seasonal business. I might actually want to do something a little bit different for the month of October this year. So maybe I need to change what my actual layout looks like instead of just knowing that Google's going to take care of scaling the machines as needed.
Mm-hmm. Very cool.
One other huge advantage for us, Google BigQuery. BigQuery is our data warehouse service. So you're talking about petabytes of data here, not just small storage of gigabytes, so to speak. And BigQuery is something that we spend a lot of time on. It's in almost everything we do. Especially when you look at large enterprise companies and the amounts of data that they have. It's as I said, it's petabyte scale. It's globally available. It's a completely managed service. Imagine loading all those 5 petabyte images of light sheet microscopy into Google Cloud, having a bunch of data tied to that, and I'm doing that within one region. Will automatically take care of replicating all of that data globally. So now someone in a completely different region across the globe can have full access to that, and they're going to have quick access. They're not trying to ping it all the way back to where you are. Right. It's like I said, it's fully managed serverless. You can stream data into it. It has built-in machine learning already, as well as GIS. I think GIS data. So you're talking about like global. I forget what GIS stands for specifically, but like latitude and longitude.
Like global information systems or something like that.
Probably, yeah. Location data. So that's a huge
geographic.
Built into it. Geographic.
Sorry. Yeah, geographic. Yeah.
So that's built into it, and you can continue to pump all this info into there with built-in machine learning capabilities, a built-in BI engine on top of it. A great example is, let me take all of my Google Ads data, a bunch of my marketing campaign data. Let me take data from my CRM to put it in there. Maybe I have some info from my ERP, and I want to push all the CRM, customer relationship management, your sales service, ERP, my enterprise warehouse planning system, where I'm doing supply chain, things like that. I gotta make sure I don't assume everybody knows these terms, but you're basically pushing all this info for a huge international company into BigQuery, and you're bringing it all together. You're running extremely fast queries on it using simple SQL, and then start to apply machine learning and start pulling out trends. So now I can start doing better customer profiling, or start doing a little bit better demand forecasting based on some of the other metrics I've seen of what people are actually searching for on the web and whatnot. So BigQuery is that's like a story all on its own. It's a really cool thing that we use everywhere, at least in what I do. And it's, as you get it, especially into the enterprise space, it's awesome. It's a really cool, powerful tool.
Yeah, I'm very intrigued. I've never used it, but I just wrote it down on my notes and I put a box around it to come back and personally explore that more, because that sounds really, really interesting. One of the just to kind of fill in the audience here, is that one of the big problems that very big companies start to face is when you have absolutely massive amounts of data, is like, sure, you've got all this data, but to even run, let's say that you want to figure out, and this is, I'm going to totally oversimplify this, but let's say that you've got 10 years of data on, you know, Halloween costume purchases, and you want to figure out what the average price, like what the average sale is, right? And so you can run a very simple query like select average sale from sales over the last 10 years. And that query can take minutes to return, right? And it basically is so slow that it's not, if you're trying to run any kind of real-time service, it makes it unusable, right? And then
yeah, sometimes hours or days with really large data sets.
Totally, right? And so these kinds of solutions, like BigQuery, are kind of like the future of really, really, really being able to leverage these massive amounts of data that you have to, you know, inform and better decisions. So really, yeah, I'm super intrigued by that.
And like to add on to BigQuery itself already, we just this year released BigQuery Omni, which is now being able to provide BigQuery UI, and then being able to pull in data from Azure and AWS, all from your own BigQuery UI space. So I can actually now analyze data that you have stored on your AWS instance. I'm not necessarily replicating data back to Google Cloud, using the power of Anthos, which is Anthos is like a multi on-prem tool. Like, how do I have something in cloud and on-premise or in another cloud? But basically, you can use BigQuery in your other cloud providers and what you have in Google Cloud itself. So you're now with a lot of companies that are have some type of multi-cloud strategy. Some companies will be all in on one cloud, but a lot of large corporations, they're all about multi-cloud for many good reasons. Or if you have different projects that you're working on that you know are on different clouds, you can actually take advantage of the power of BigQuery with the different data sets in all of those different clouds, which is really, really cool. That's one of the newer fun things that we've released this year.
I'm kind of visualizing like a Pac-Man situation. Google Cloud is like, we see you Redshift, and we'll go ahead and just absorb that into BigQuery.
Totally.
Yeah.
Yeah, I mean, and it's true. Like, people are going to be highly invested. I mean, like you said, you've used AWS a lot, and like,
yeah,
great. That doesn't mean you have to shift to Google Cloud. How can we find a way to meet you where you are and still provide a ton of value in these tools that we have?
Nice.
And we're doing more and more of that, and that's just a really cool example.
Cool, very cool.
Awesome. So those are like some of the few kind of biggest things I see. There's other differentiators that are out there, but I really wanted to jump into AI and machine learning. Obviously, for Google Cloud, for Google itself in Google Cloud, ML is deeply ingrained into everything we do. With all the products that have been around, this is just kind of a one glance over of all these different products of how do you bring all this, ML capabilities into the different products you have. I'm a huge person on YouTube. I constantly watch videos all the time, whether it's myself or with my kids, and I love the video recommendations. I found great new channels just based off of those. Or I have a lot of products where I use Google Assistant in my house. So I will use it to play music or tell me about the weather. Whereas my daughter wants to listen to Disney songs or translate something for her, she's in Spanish immersion, so she needs to translate a word from Spanish to English. And so there's a lot of history in machine learning with Google. There's a lot of data that's passed through Google. And I don't want to make it sound like Big Brother-ish. We obviously have boundaries, but we also have a lot of things that we can use to improve our ML models that we have, and they've been improved over a long time. And so we're trying to provide the power of that back to people. A couple just cool examples. Google Translate. I literally use this every single day. Like I said, my daughter's in Spanish immersion. She's in first grade, and I don't really speak Spanish, or I speak mostly words that she shouldn't know. So I need to use Google Translate for that a lot. And even a better use case of this is I was in Japan a couple of years ago, and I was in a taxi on the way back to the train station in Kyoto, and it was right when there was a big earthquake in Osaka. And I didn't feel it in the car, but I got to the train station. And if you've ever been to Japan, their train system is insane. Like, it is on point, it's fast, it's precise, it's never down. And everything was stopped. I was shocked. I'm like, what is going on? I don't speak Japanese. I don't even have any idea. There's other people around me, from other countries that don't speak Japanese that are like, yeah, I don't know either. I was able to pull up my phone, use Google Translate to translate real time what the guy was saying over the loudspeaker. So I could see what he was saying in real time in English. as well as use the imaging, like in this picture, this GIF here of, what's scrolling across the board, to realize, oh shoot, there was an earthquake. Like the trains are shut down right now. I got to find a different way because my flight was like, 5-6 hours later out of Tokyo. So it's pretty powerful, like how good our translation app is now, and I love it. I use it for so much stuff. It's and it's fun to test something like this where you can quickly translate something and see it, and just see how fast and powerful it is. And that's all going on your device through the app itself.
I've used that photo based one quite a bit as well, because we've traveled pretty extensively, and so there's just no way to keep up with all the languages, right? Or even sure, you can study for 2 weeks before you go to a new country, but that app has come in very handy for me on several occasions too. And I'm one of these days I'm a Pixel owner, and
nice.
I haven't actually I haven't actually started to use it yet, and I'm not even sure if it's fully out, but I've always really I think you were actually just explaining using it, but the idea of it, did you ever read The Hitchhiker's Guide to the Galaxy? What is it, the Babelfish or whatever that they put in their ear, immediately translate any language. The idea that that's basically at our fingertips now, that you can be anywhere and you can have a headphone in and just turn this app on and immediately translate the conversations happening around you, to me is just, it's the future. The future is now.
Totally.
Cool. Yeah.
Yeah, and that's like that wouldn't be possible without like incredible ML models that are built for all these languages, and then also like edge devices, right? Like we have Edge ML where I can have that kind of translation on a specific device I have somewhere without connectivity and still have like instantaneous translation of the stuff. So it's really cool. It's super powerful.
Nice.
I am obviously a Pixel user too, although all of my iPhone friends hate me because I ruin our text message threads.
Likewise.
But I love it, and one of those is Google Photos. Like,
yeah,
I have so many photos, and they're, especially now, I guess I have 3 kids. As they start to grow up, I'm like, oh, what was that one photo from that one time where we were at some park, and I can just go in there and quickly look. Oh yeah, here's photos of my daughter, and it'll show me photos that contain her, and I can quickly look back and like pull something up, and I'm like, oh, that's right, remember that? And they're like, oh, look at that, there's a video, and play it, and like, it's fun to look back to those memories. But Google Photos is a good example of really doing well at looking at the images you have and helping classify and kind of orientate the data of those photos for you.
One of my favorite things to do on Google Photos is to go. There's an option where you can just click on people, and it basically is just this. It looks like the screen on the image here, but instead of all the pictures of dogs, it's just a picture of everybody's face that or that you have a photo of, right? And so for me, it's basically like scrolling through all of my friends and family, like sometimes, like for instance, if you're feeling lonely or you haven't seen during quarantine, I could just go, it's basically just like, it's just a single photo of all the people that I love around the world. And it's super fun to just go scroll through like, oh, hey, oh yeah, and have all
look at that.
Yeah, because it just recognizes the faces, and then when you click on any one of the faces, it'll pull up all the pictures you have of that person. A little creepy at times, but also really cool.
It's like one of those boundaries where some people are really comfortable with it, some people are not. I fully embrace it. I love the convenience of it all and like the power. So I'm fully bought into it. I probably have a Google device in almost every room of my home, so I'm sure they hear everything I do and say.
Right.
But
the nice thing about Google is that they, what was their Sergey and
Larry,
don't be evil. That's always seemed to be like a pretty good ethos of Google's, and it seems even through all the decades and absolutely how massive they've gotten that ethos has remained. You know what I mean? Like I have
completely
trust, and I just kind of trust Google more than I trust any other company. Like I wouldn't put all my photos on any other service, but for some reason it seems like Google is not evil, and so I'm basically fully bought in on the Google as well.
Yeah, and there like people will be surprised how much is in place to protect your actual data. Like it's incredibly hard to get access to any of that, especially without you knowing. There's just no way. And I know there's lots of camps of how to get your life off of Google and things like that. I totally get it. I'm fine with that. But yeah, we take it pretty to heart. Like we being Googlers, other employees at Google, and Google as a company, like we if we didn't have people's trust, we wouldn't have users, which means our products would be useless.
Right.
I'm going to jump ahead of this. Smart
Sure.
reply and email. This is also interesting, but I'm going to start going through more and more examples. But just another place where we invest a lot to, help your productivity, so to speak, which I spend a lot of time on email. So, but this is cool. So, this starts going into how do you start to make ML more consumable? How do you democratize machine learning and AI so that others can use it, if not just data scientists? And so this is kind of a cool graphic that was created to show who can actually use AI. Well, when you look at like how many people are out there of actual users, and I don't know if this is what user base this numbers come from, but it's just a good example to show that there's data researchers themselves, like data learning, data scientists. They know it inside and out. That's what they do. There's ML experts on top of that, which have an even broader sense. But then you have lots of developers, and then most people are business users. And so the point being that like people really traditionally who could actually do this kind of stuff is really small. This is two small groups at the top, the red and the yellow. Developers maybe they have some type of idea. I know I certainly don't. I've tried to kind of pick it up, and I'm like, I will personally probably not use it, especially since there's things that I could use in the meantime. Whereas like business users, it would be awesome if you can power all 100+ million of those business users to do some type of machine learning on their own and not have to be a data science expert. And that's kind of the goal behind a lot of what we're investing in, is like, how do you help democratize this and get all these other people in there? Because now you're going to start finding more and more powerful ways for people to consume data and get insight and use out of it. And they need to be able to do that in a really easy, foolproof way. And so it's some of the stuff I wanted to show you today, and what I'm getting into. We obviously have within Google Cloud, within Google Cloud Platform, a ton of stuff. Whether you are those like deep down data scientists and you're doing TensorFlow models using Spark, Apache Beam, you want to be able to take advantage of cloud TPUs. TPUs are processing units that Google themselves built specifically for TensorFlow processing to help speed that up. And that actually goes to your point of you're talking about, cloud platforms and how do you, increase your capacity and the time for usage. If you're doing a ton of TensorFlow modeling and processing, that on a traditional hardware system, you're very limited on what you have. And so you might be waiting to process all this data through a model for a long time, days, hours, whatever it might be.
Right.
Within Google Cloud Platform, I can actually take a bunch of machines, specify them to use TPUs, and I can run TensorFlow models on extremely large data sets in a very short amount of time. And it scales it up really quick, runs my model, and I shut it back down. And I'm only paying for that little bit of time that all that was actually being used. I'm not paying for hardware over a long set of time.
Right.
So you can be super low level if you want to. And we fully support a number of different tools to be able to do that. But as you move into the Cloud AI building blocks here, this kind of middle part, this is where we start to democratize some of that stuff, where you actually have APIs that out of the box already have models built behind them based on a lot of what we already have today. So we were talking about the translation, right? Speech to text and text to speech. I can actually use the Google Translate app to do that type of stuff because of APIs like this. And you as a developer have access to those APIs on Google Cloud's platform to use them within your own applications, whether you're providing it into some user interface or you're doing it behind the scenes. You have APIs for natural language processing. So how do I actually take a document or some large set of text and try to get out the bits and pieces from it? Is it talking about people, places? Is it positive sentiment? Different things like that. You can do video processing. One of the cool stories is how we use this within sports, right? I'm a huge Niners fan, diehard Niners fan. Being able to analyze like video of the Niners and see, oh yeah, this is a football game with the 49ers. And, Jimmy Garoppolo threw a touchdown pass to George Kittle. And there's this many defenders in the area. Like that kind of stuff is what you can start to do with these APIs. Or Vision API, which is one I'll show you today, which is around images. And those are all out of the box. They're pre-packaged. You as a developer can get access to those APIs and make REST calls against them now. To take it a step further, I can use what we call AutoML. And there's a lot of AutoML services. In fact, this slide isn't even fully up to date. There's more. There's one for video. That you can actually start to build your own custom models on top of those. a really simple example. This is very basic, but Vision API can tell you that a picture has clouds in it. Well, what type of clouds? Well, you can use AutoML to then train it to know that, oh, this is, this type of cloud. Is it Nimbus and Cumulus and whatever those are? I forgot all those from school, but
yeah.
But you can basically like train your own models and customize them to your specific use case and your business on top of what's already there out of the box. And I'll show you that, an example of that as well. I think this is like the area that excites me the most, because it really makes it simple for almost any developer out there, and even some more savvy business users to start to consume machine learning and embed it into what they're actually doing.
Yeah, it's fascinating. To me, you kind of touched on it, but this goes so much further than kind of even where my head previously was, where the idea you were talking about, spinning up, you like a number, and pardon my verbiage here, but like basically spinning up a number of instances to process some to run some model and TensorFlow, and you can spin up 100 of them or 500 of them or 1,000 of them, run them for 7 minutes, and then they spin down, and that's all you pay for, right?
Totally.
That to me right there is so fascinating, because this kind of processing power up until a few years ago was limited to Google and these other kind of absolutely massive international companies that had these massive data centers. But now any old developer, you, me, or anybody else, can basically have access, and with a few commands and a few clicks of a button can spin up 1,000 virtual machines, run some crazy machine learning model through it, analyze an absolutely ridiculous amount of data, and then spin it down 12 minutes later, and all you paid for was 12. The amount of potential at our fingertips with these tools is obscene. It's wild. Yeah. And the fact that I really am excited to learn more about these, what you have in the cloud AI building blocks, like the prepackaged and custom and automated, because basically, if I'm reading it right, instead of you having to write your own model to determine, to do any kind of translation or any kind of image processing, etc., that's just already there. That work has been done. Now you can just leverage it, which is amazing.
Yeah, why should we make everyone else learn how to, make everyone else build their own models that can identify that someone's wearing a hat in a picture, when we have that kind of stuff? Like Google Photos is using that all the time.
Yeah.
And so, like, why not open that up to the world?
Yeah, totally.
And then we have some other stuff, more AI solutions, like call center AI is a big thing for us, document AI. Basically, how do we build more specialized, very unique use cases, which I won't get into right now, but those are like call center AI is a big thing for us as well. So I already talked ad nauseum about this, but basically it was to double click into that. So with that, let's look at some of those.
Sweet, let's do it.
That sounds good.
Yeah.
So this here, this is a URL that, if you have a Google account, you can get into. And Google account, Gmail, G Suite, whatever it is, it's basically a public URL that you can get into and test this out. This is our Vision API. So this is the API of, I can send an image to it, and it's going to give me a bunch of info back. And so this is kind of cool, because anybody can go in and just test it out. So let's take, nope, not that one, sorry. That was not the one I wanted. That's for a different demo. That's for my next demo. I want to take Jerry Rice here. The man, the GOAT. So this image, I'm putting it in here. It knows that, okay, yeah, this is a person. Oh, look, there's a football helmet. Cool. Pretty confident scores in those. Sports gear is high. It's definitely football. This is a player of some type. And so it's giving me some information around it, and it's confidence scores within those. Any logos. Oh, yeah, look, San Francisco 49ers. What do you know? Text, yep, there's the number 80 on his jersey. And then other properties around like color and, cropping hints. And it'll show you all that kind of stuff, so you could see it. Safe search, which is also interesting in very specific cases. But this is cool down here. You can see like what's the request URL and what's the response look like. So you can get an idea of what it's actually going to look like and test it out and kind of start to prototype your own code around it before you even actually hit the API itself from your actual application that you're building. To pick a different
pretty
file.
Amazing. Consider me impressed, man.
I love it. Like, I think it's really cool. When I first got here, I was like, and I had no real experience into ML. I'm like, this is awesome that I can do all this. George Kittle, tight end, he's a beast. I said, diehard Niners fan. So Is he angry? Yeah, he might. We know that he's probably not angry, but this is saying possibly
Passionate.
angry. Yeah,
Passionate.
he's passionate. Exactly. But again, he's wearing gloves.
Uh-huh.
He's let's see, player. Typical thing you saw in the last one. Text. This also identifies his number. There's the captain logo on there. Things like that. So this is really cool. Like I'm not doing anything for this. Like I'm getting all this info for free just by putting an image in there, and it tells me all this stuff. So if I want to start to do some analysis of some type of image, I can do that from here. More real world use cases of it. There's people doing this with like a driver's license, for example, right? I may be a mortgage company and I might want to get some type of info. I can take in an image, and you got to be careful around what you build and what people have access to. But this will go ahead and identify, like, yeah, here's the picture, here's the text of the driver's license, so I can get their name, their license number, their address, things like that. And we have other services. A really cool one, I didn't have it in here, is our de-identification service, where you can pass it info, like a driver's license info, or social security number, things like that, and it'll redact that info for you and send it back to you and store it with a key. So now I can actually process like sensitive information, be able to store it, and be like HIPAA compliant, for example, within a healthcare scenario. Do PCI processing. And so you're starting to piece together some of these different APIs to be able to do that processing and solve real problems that people are facing in the world, and be compliant or secure, things like that. So this is just like the out-of-the-box Vision API, and this is cool just because it's nice that anybody can go to this, try it out, plug in whatever image you want. Kind of fun just to see what it looks like, and then, like I said, you can see what the JSON actually is, and start to prototype around it. So when you actually do get access to a project being the actual Google Cloud Platform project where you're building all this stuff, you're already kind of ready to go to plug and play the API.
It's really neat. Two questions. One is a silly one. That looks like Lake Tahoe there, yeah?
You know it, baby.
Nice. And the second one is, and you've already mentioned this, like with REST, REST calls, but and maybe it's more of a comment than a question, but this is all accessible via RESTful APIs, correct?
Yeah. Yes, it is. This is all accessible between RESTful APIs, and there's also CLI. You can do this within the command line as well. It doesn't have to be through a web call itself. So within the G-Cloud tool, you have that ability to run these things too.
Gotcha.
Cool. So that is Vision API. That's like out of the box. Throw in any image, and you're gonna get some good kind of generic analysis around that image, so to speak. But cool, that's very powerful, but I have very unique use cases of what I'm trying to solve. Awesome. AutoML can help you with that. And so AutoML is, how do you take that Vision API and then start to adapt your own model on top of it? The example I'm going to show you here is we were working with one of our GSIs around manufacturing use case. And how do you help somebody who's walking around the floor, floor manager for a steel manufacturing plant, to help quickly identify problems with steel sheets that you're producing. And so we built this POC where we actually took the Google Glass, the like glasses that can take images and things like that, and we built this model. And so you could kind of walk around with these glasses and have it, look at a sheet of steel and identify, oh, yep, there's an image, there's a problem with that one. Let me quickly, use it to send a report up to, the plant manager and things like that. And so this model that I'll show you is specifically around steel and problems with that. But before I do that, let me just kind of talk through some of the steps of how it actually works so you can get an idea of how do you build your own image, or your own model. So you start out, this is the Google Cloud Platform itself. This is the console of where you actually do everything you need to. You can see there's a navigation menu with all the different services, IAM, etc., App Engine, Compute Engine. So we're going to set up VMs and things like that. This image right here is around a data set that we built within AutoML for Vision. And there's a few kind of steps. It's not too complicated, thankfully. First off is you create a new data set and you need to give it some images, right? You need to start training it. Now, I am not familiar fully with how I would actually build a model, like in TensorFlow, things like that. So I have no idea how that all actually works. This happens behind the scenes for me. All I know is that I need to provide up images in here along with labels for those. So it knows how to train that model.
Okay.
And it'll build it for me. So the idea is that for each image type that you're trying to do, and you'll see in a second what I mean, you should have, I think it's a minimum of 10 images. So you can do it with like a pretty small amount. I should double check myself on that, but obviously we recommend at least 100 images. So with any machine learning, the more data you have, the better. But you can POC, like build prototypes with this with very little amounts of data and very little time. So you can just upload a bunch of images and go through and label them, or very easily you can provide a CSV file in cloud storage, which is just like Google Cloud's bucket storage. So like what I did is I took all those images that I have, I put them in a big folder in cloud storage, and then I had a small CSV file that said, this image within cloud storage is of this type label. So I can easily write a script to build that for me. And then I upload it in here, and it'll go ahead and process that for me. So I have those images in there. Here's what it looks like. So you can see there's a bunch of different images around steel, of different issues I might see, crazing, inclusion, patches, etc. So this is my data set. This is what I actually initially loaded to train the model on, right?
Okay.
Now let's actually go train it. So you can see I have a number of different models, but I would say train a new model. You give it what type of, what the model should actually be, a name for it. If you want to be able to use it for offline usage, cool, you can do that. Not a problem. Like we talked about Edge, for example, like I may be somewhere where I don't have connectivity. Fine. You can build a model to be on an Edge device. And then there's some things around like budgeting, how many hours you want it to run. You can do it in as simple as in like an hour. So I can actually I can train a basic model within 1 hour. Which is really cool, especially if I'm just trying to like prototype it. Like I said, I spend a lot of time just prototyping, so I love that. If I go over into like 24 hours, I'm going to get a much better model out of that.
So one quick question: you had a bucket full of images, and then a CSV file, and for each one of those images, did you say like inclusion or pitted, or like did you give it with those labels on the left? So you gave it an image and said like that image that your mouse is on right now. In the CSV file next to that image was the word crazing.
Exactly. Right.
Okay.
Yeah. So for every image, that CSV file had a label attached to it, and it'll tell me like, oh, you have some that are unlabeled, go in and label them. But yeah, so all that CSV file did was actually apply a label to each of those images. So it knows that, okay, this is what pitting means. These are all examples of pitting images.
Got it.
So that way, then when I tell it to train, it's just going to take all of those labels and start to build a model of, okay, here's the images of pitting, boom, here's the images of crazing, boom. And so it can go around, it'll build those models for me. It gives me all kinds of info on, all of this doesn't necessarily make sense to me. So there's probably things that make sense to more people, but, prediction, because you also it'll use some for testing to see, what did it find against and so you're giving it data to say that, okay, yes, this is what you should use to show pitting, but here's other pitting images that you can test against. And it handles that behind the scenes. It takes a subset and tests it. But it says, here's all the images, how much did it actually test with? So I had, 1,600, 1,700 images total. I had 13,000, sorry. What was the precision on it? What was the recall? So some of these things were, false negatives. I'm not always as clear as these. I apologize. But it gives you kind of insight on what the model is actually built, so to speak. So how well did it put that model together, and where off is there confusion within the model, so to speak.
And so if you scroll down a little bit, is it telling you in that table below that when it comes to scratches, it's 5% of the time it's not able to tell whether or not it's an inclusion or a scratch?
Yes, exactly. So yeah, it's saying there was 5% that was like, oh, that might have been an inclusion. I wasn't exactly sure. And so you can see more like detailed breakdowns of this.
This is so cool.
But like, that's all it is. Like, it's all I had to do to build a model. So now I actually have different versions of models. So you can apply, different bits of test data to it and training time. So I might have one that's just a POC model, but I have one that I want to train that's more real world. That's fine. And then I can just test it. I can test it through an API. or very easily, you can see there's Python scripts, so like the G-Cloud tool, that's like the library you can use within scripting. Let's take these two and just load it and test it out. So, yep, we know this one was patches, but it's telling us this one is patches. And same thing down here, pitting. So we know this is a pitting image, just because we know that by having it, but it's telling you, yes, this is image pitting. We're 100% confident on it. So with like a pretty small set of data and, like I said, like an hour minimum time of training,
Right.
I can actually build a model that's, not too bad, especially for somebody who's not a data scientist at all. And then I can now go ahead and deploy this model, and I can use it within a larger infrastructure that I built within Google Cloud to, process other large data sets that come in and run models. And I can continue to keep iterating on these models, so I can keep retraining them. It's not like I'm stuck to it, which is important, right? Like I said, with the machine learning, the more data you have, the better. Just keep training that kind of stuff.
So for years, I've always wanted to build an application that can help track whales. I'm a big cetacean enthusiast, like whales and dolphins and seals and sea lions and stuff like that.
Nice.
I lived in the Bay Area for many years, and one of my favorite things about living there was going out and seeing the whales right off the beach and going whale watching. And like right off the coast of San Francisco, we've got blue whales, gray whales, humpback whales, orcas, and a lot of them are migrating, right? So there's a huge migration of humpbacks from Alaska to Hawaii, right? And they come down the coast of the U.S. And one of the problems of understanding whale populations has been tracking them, right? Because the way that whale tracking currently happens is that oftentimes it's a bunch of there'll be researchers out there, and they take pictures of the whale's fluke, the tail. When the tail comes out of the water, the tail is kind of like a whale's fingerprint. They're pretty distinct, each one of them. But the messed up part is that, like, Alaska and British Columbia and Washington and Oregon and California and Mexico and Maui, there's groups of people in all of those places that are taking these pictures, and they're actually, I'm sure maybe it's gotten a little better now. It's been a while since I checked in, but then what they would do is print out these pictures, and they have like a team of volunteers, oftentimes kids, like teenagers and volunteers, that literally look at a picture and then flip through the book of the whales from last year looking for a match. And I've always thought it would be so neat to build a web service where you could basically crowdsource that. So like anybody on vacation in Maui who took a picture of a whale tail could upload it to this website, and like it would help with like understanding the populations of whales and who's returning and all this kind of stuff. But I've been scared away from doing it on several occasions because, one, I got really serious into it once, and I started looking into how to work with like image recognition, and it's really tricky stuff. Like really quickly, it's easy to determine the difference between a square and a circle, but between one whale and another, based on like the different coloration patterns. And so it's been like this pet project dream of mine that I've wanted to build for a very long time. And in you showing me this, all of a sudden I'm like, holy cow, this is totally doable.
Totally.
You do need the data set up front. So you do need to know that this whale tail belongs to, some, or maybe you don't. Maybe you can just say these two images, whether they know this, the name or not. But and then what you could do, just to kind of tie it together, or what I'm thinking of, is you can basically have a website like whalerecognition.com or whatever. On that website, it's just your website. You can put whatever you want on it. It's got the option for people to upload pictures. But when that picture gets uploaded, you can transfer that picture over to Google Storage. That Google Storage bucket is already hooked up to one of these machine learning models, right? So behind the scenes, behind your website, basically you can be leveraging all this incredible machine learning stuff. I think it might be time for me to dust off that old project and give it another go.
Do it. Nice. And even better, on top of that, to encourage you or entice you to do that.
Nice.
You could start it for free.
Beautiful. That was actually going to be one of my closing questions. Like, how do I get started and what's it cost?
Not to jump past what we were just looking at, but like, so there's, we'll get to the certification in a second, but so you could do a lot of stuff for free on Google Cloud. So there's already some things that there's free usage limits. And this link talks all about it. So you have the capacity to do certain things without paying a dime. But as of right now, is for new people that sign up, you can actually get, I think it's like $300 for 1 year of credit to use on Google Cloud. So that link, this link will tell you what it is in real time. But like before I came here, I knew nothing about Google Cloud. I took 3 months and I studied every night, and I just to get certified, which is the other side of it. You know, there's certifications which are awesome. They're really diligent. They're challenging, but it really gets you to learn what Google Cloud can do. And there's professional architect. I'm doing the security one right now. There's a developer one, networking. But it's cool. Like I just went on, I signed up for an account. I got the $300 for free, and then I could go in and I could play around and do whatever I want, burning that credit, not having to pay a dime. Also knowing that there's some things I'm doing that aren't even burning that $300 credit.
Right.
But it's really easy to be able to get in and get started. And there's tons of information out there. There's Coursera, which has tons of classes as a paid service. Like I actually found a bunch of stuff on Udemy where you can get classes that other people have written for like $10. There's tons of documentation that we have that's pretty well written and detailed. So like it's really easy to go out and get started building stuff on Google Cloud. And like that's awesome. Like I love that you brought that up because that's such a cool project. And I bet you could go in and like prototype something in not too much time and have a basic POC up and running quickly.
Right. Totally. So when it comes to so let's say after you get beyond the free tier, I'm assuming obviously it's like you've already mentioned, it's a pay for what you use kind of situation.
Yeah.
So is it possible, like, are the prices, and this is kind of a leading question probably, but are the prices, like if I'm, Coding Nomads, we're a small business. We run a number of servers. We've got a number of databases. We've got, a number of things going on. And for us, it's really important to have access to all of the, this cloud stuff, but we also don't have $10,000 a month on an infrastructure budget or beyond.
Why not, man?
Yeah,
we love your spend.
Yeah, and also, we're also going to have some Google Cloud certification courses in no time. So you can go to Udemy, Coursera, or Coding Nomads. Just give us
Coding Nomads would be even better.
Yeah, just give us a couple months. But like, what's the cost structure look like when you get beyond the free tier? I'm curious. Is it?
Yeah, it really depends on what you're doing, but like in general, and I say this with a massive grain of salt or a big asterisk because prices always change,
Right.
and companies will, especially if you're looking at bigger commits, companies always change prices. But Google Cloud is actually really affordable in comparison to a lot of our competitors and what's possible. There's a ton of stuff you can do for a pretty decent price, and it's really not until you start putting in more and more larger sets of data that you start getting into even other ways to how do you slice and dice how you pay for things. Like our VMs, like not only is it super flexible in what you can build, but you pay, like you said, only for what you use. We actually look at, let's say, take over a month what you actually have used, as you turn the VM on and off and things like that. And we take all those chunks of time and we actually put it all together and you get discounted rates. So like continued use rates on top of that. So we don't expect that you're going to spin something up for a month and we're going to give you a discount on that. We want to know what you did over the month, and if you did enough, cool, we'll actually give you a better price because you're using more. We know that you won't need to use it all the time. You're using a cloud infrastructure because you don't want to use it all the time.
Right.
And so, yeah, overall, like pricing is fairly competitive when it comes to Google Cloud. A lot of people will use it and try things out. And I think that's one of the big reasons why, is that you can do it for a pretty good price. And I didn't mention this actually as a key point, and I totally should have. We are very friendly with open source type stuff. So there's a lot of things that we're completely fine with people using open source stuff. We have a lot of like managed services ourselves that you can see that other slide. But like you can use all kinds of open source libraries within our environment, and we're cool with that. We support a bunch like on our marketplace. I don't know the URL off the top of my head, but we have the Google Cloud Marketplace where you can easily like one-click install different libraries and services. So even more so there, if you're already familiar or have something built out, with like Spark and let's see, I can't think of the name, but like if you have a whole Apache environment set up, we have like Dataproc and like managed services for those. But if you want to use your own, like great, you already have models built, you have pipelines built, awesome, load them in, and you can use VMs for a ton of this stuff at a great price, and that's totally cool with us.
Very cool. And then this might be, pardon me, a too specific of a question, but do you have any idea what what a monthly cost is for a small VM? Like, let's say somebody wants to, get started with Google Cloud hosting their first web service, right? Do you have any idea? And it's just really small. They're just getting started. Like, do you have it? And I don't really expect you to know this off the top of your head, but like to run like 1 or 2 small VMs, are we talking $10 a month, or are we talking $100 a month?
That's a great question. I don't know off the top of my head, but we got the pricing here somewhere. It's slowly loading. Within their documentation is all the pricing. It's pretty low. Oh, I know. Let's do this. Oh, there we go. It's just taking forever. So in Iowa, the U.S. Central 1 region, at an hourly rate, for a very basic 2 CPU, 8 gig, you're running 6.7 cents per hour.
Per hour. Gotcha.
It's pretty good. And then actually, I didn't talk about these either. You can get preemptible machines, which are way cheaper. Those come at like an 80% discount. What a preemptible machine is we give you, we obviously have a bunch of compute capacity sitting around that, people may not be using. You can choose to get a preemptible machine, which means that it runs for 24 hours, and you can get a notice where that machine will have to shut down in like a super short amount of time. So you'll have to have like scripts built in that, okay, if I don't get to finish what I'm trying to do, that this machine can store data or do what it needs to do and shut down. And you're talking like seconds, so to speak, but you're paying a crazy low price. So if you have workloads that aren't like critical, you can use preemptible machines and save a ton of money. But even so, if you're just running a service, like you said, that someone's just starting for basic, I mean, and that's in Iowa, 6 cents for that. If you want like Oregon, I don't know if it's different or not, not in this case, but yeah, so I mean, it's pretty affordable. Two virtual CPUs and 8 gigs, 6.7 cents an hour.
Yeah, so like $30, $30 to $40 a month to have your own server. That's not bad.
Yeah. So the last thing I wanted to show you, and I actually just randomly found this, is it's kind of a cool cheat sheet that somebody put together of like all of Google Cloud services in, what is it, like 4 words or less, it said. So if you go to this link, you can see it on there. There's obviously tons and tons of services. You will not likely use all of these services, but it's just the breadth of what's on there. And this is just kind of a cool cheat sheet I found that I thought would be fun to share. I've used this before. It's a kind of a good way, especially if you're new to Google Cloud, to kind of get an idea of what some of these things are, or if you know of a service you might want, you can probably better identify it in just a few words here and then be able to jump to it.
Got it. So this is like how to understand each service in 4 words or less.
Exactly.
Beautiful. Yeah, I mean, there's so much to know and so much to learn. So thank you, 4words.dev, for making it easy on us.
Totally.
Very cool.
But that's all I had, man. Hopefully that's a good intro to Google Cloud on some of the things that are more unique to it. Quick touch on the breadth of it, but like I said, I really wanted to showcase the AutoML and the built-in ML capabilities. Yeah.
Well, thanks, bud. Here, let's go ahead and, if you don't mind, let's hop back on the videos.
Yeah. I need a fan awesome. From here. I'm like roasting right now.
That was really cool. Really, I'm fully intrigued. I wasn't expecting to come out of this with all kinds of project ideas and wanted to pick up old projects that I've been dreaming of for years. It's really cool, and it's really nice to talk to you. You're clearly super knowledgeable about it, so I really appreciate you. I had written down some questions, but you covered them all as you spoke. So I actually don't really, I mean, I could ask you questions forever, but I would just like to thank you for your time and for sharing your knowledge with us. It's really awesome. And to get somebody that's inside the Google, that knows the ins and outs of everything, to explain it all to us is a pleasure. So thank you so much.
Yeah, thank you for the time. It was really fun to be able to show this, and who knows, maybe in the future I come back with something even more interesting and different, unique to show you. So,
and anytime you want to talk to us, we're here. We're here to listen.
Nice.
All right, bud. Well, again, thank you so much for your time. Really appreciate it, and we'll see you soon.
Thanks a lot. Take care.
Bye-bye.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.